Hello, welcome to Advanced Algebra 2. Here we are, we're going to go ahead and talk about solving radical equations. Now, of course, radical is just a fancy word for some kind of square root-ish. It can mean cube roots and fourth roots and stuff, but for today, just square roots. Okay, so here we have our first example, and we're going to solve x equals 3 plus the square root of 24 minus 4x. Okay, so we're going to have to square it because of that square root thing. If you square it right now, the 3 and the square root term are going to mix. When you FOIL it, it's going to be a disaster. So, strongly recommended you isolate the square root. That means you put the square root alone on one side of the equation. So, in this case, subtracting the 3 from each side will make x minus 3 equals the square root of stuff. Now we'll go ahead and square root each side of the equation. Square each side of the equation. Remember, this means not just square each term. Gosh, that would be easy. But no, you have to square the whole side of each equation. Now, squaring x minus 3 is, slightly annoying, but x squared minus 6x plus 9. If you don't see it, you can FOIL it. Just write two of them next to each other and FOIL it. On the right side, it's actually pretty sweet. We just have 24 minus 4x. Oh, okay, well then you add the 4x and subtract the 24. You have x squared minus 2x minus 15 equals 0, and so you spend some time feeling all factory. And so now we have our two answers. We have x equals 5 and x equals negative 3. Wonderful, except we should probably check them. So if you check 5, it actually works out. You just take 5, and when I say check, I mean back in the original equation. I make a big deal about this now, right? So when you check, you're putting them back into the original equation. Don't put them back into the thing after the squaring. You'll fool yourself. Put them back in the original equation. Okay, so I've made my blue point there. When you check negative 3, it doesn't actually work. The check fails. Now, I'm not going to really show you, but you take your negative 3 and you substitute it in, and you end up with, I think it ends up as 9 on the right, whereas it's negative 3 on the left, and they're just not the same. So the check fails. So what we have here is an extraneous situation, just like with logarithms, just like with rational functions. Negative 3 is extraneous, meaning negative 3 is an answer that's wrong, but it's not your fault that it's wrong. It's just your fault if you continue to think it's right. 5 works. 5 is our answer. Yay! Okay, here's our another example. Now, this one is grosser because you have 2 square roots. You might think, I'll just square it. You will, but you can't just square each of the nice pieces. You have to square the whole side of the equation. That's going to cause problems. Now, here's what I'm going to recommend. When we do it, there's no way of making it nice, but it's a little bit better if we have 1 square root on each side. So on the left you have square root 4x plus 1. On the right, 5 minus square root of 3x minus 2. Okay. Now, if we go ahead and square both sides of the equation, and here I'm writing it out as a separate line, just hopefully to give you a better visual of what's happening. When I was doing it myself, of course, I would just write blah squared on top of the work from before, but whatever. All right, now on the left, super nice. It's just 4x plus 1. On the right, okay, so 5 squared is 25, but then we have to double the middle term, so it's minus 2 times 5 times the square root of 3x minus 2. And then at the end, you have plus 3x minus 2 because that's the thing squared. If you don't see it, you might want to FOIL this one. So take the whole 5 minus square root 3x minus 2, write it twice, FOIL it out, and you'll end up with this. Okay, so here's what I did is I took the 3x from the right side and I moved it over, and I took the 25 and the negative 2, which is 23. And subtracted it over, so it's x minus 22. And then that negative 2 times 5 is negative 10 times square root of 3x minus 2. Okay, still have a square root. Hey, I get a square again. Okay, so now if I square both sides again, on the left we have x squared minus 44x plus 484. And on the right, when we square it, the negative 10 squared is going to become 100. And then the 3x minus 2 loses its square root. So the negative 10 squared became the 100, and then the square root is gone from the other part. Well, this is actually, the numbers are large, but the ideas aren't so bad. We have 300x minus 200, and so if we move it over, it's really minus 344x minus 684. And you look at that and you don't think, hey, I want to factor that. But actually, if you look carefully, the 344 is just about exactly half of it. So it actually factors fast into x minus 2 and x minus 342. If you don't see it, and don't feel bad if you don't see it, go ahead and do the quadratic formula instead. And whether you do the factoring thing or the quadratic formula thing, you should end up with the answers of x equals 2 and x equals 342. Okay, got to check them. X equals 2 checks okay. And again, when I say check, I mean in the original equation. X equals 342 does not check okay. Now, you don't know this ahead of time, so you can't just assume, I don't know, 342 looks like a bum answer. No, you got to actually do it. But in this case, 342 does fail the check. So that's an extraneous solution. I don't particularly care that you highlight extraneous solutions or not, but I'm just helping you see. And x equals 2 is the actual answer. As before, I've shown you two examples where one of the answers works and one of the answers is extraneous. And I'm doing that because I need to emphasize the need to check, to try to find extraneous answers. It is not true that you will always have one work and one be extraneous. They might both be extraneous and you might have no solution. They might both work and then you'd have both answers. But in these cases, that's how it's worked out. Now, if you would please to notice, that's all I have for examples today. So your assignment will be page 428, numbers 1 to 41, every other odd. If you have a moment, 5 or 10, 15 minutes, it would be wise to start it and try to knock out the first few, 1, 5, 9, go as far as you think you're having fun. It just would help you if you came to class with some knowledge of what you're good at and what you're not yet noticing. But that's it otherwise. So I'll just say thank you for watching, and please let me know if you have any questions.